Able to.
Yes.
So today we are moving on to start with the past papers of physical quantities and measurements, and we'll begin with the past paper of SI units first. So the first question here is state state the SI base units of volume. So what do you know about base units of volume? SI base unit for volume. This is a specimen paper from 2016, and volume is measured in meter cube. So SI base unit for volume would be meter cube simply straight away. Then it says show that the SI base units for pressure are kg per meter per second squared. So pressure, what is the formula for pressure? Pressure is force upon area. What are the base units for force? Force is mass into acceleration. Mass into acceleration. Now the SI base unit for mass is kg. For acceleration, it's meter per second squared. Meter per second squared. And for accelerate for area, it's meter squared. Simplifying this will make it kg. When you bring m power 2 to the numerator, it will become m power minus 2. So it is m power 1 and m power minus 2, s power minus 2. Simplifying it further, this will make it, this will become kg m minus 1 s minus 2. So hence it's proved kg m minus 1 s minus 2 are the SI base units for pressure. Physics works. Now the next question is the volume V of liquid that flows through a pipe in time t is given by the equation this. V upon t equals pi by 8 p r power 4 upon cl. P is the pressure. So remember, you need to read it very carefully. They already have mentioned what each of the alphabets represent. So P is the pressure difference, R is the radius, L is the length, C is just a constant, and you need to determine the base units of C. So you just rearrange this equation, and remember when you are finding the base units, you completely ignore the constants. So you do not need constants. And if I just rearrange it, it will be, have they given us V? V is the volume now. So it will be V over T equals PR per 4 for CL. Now you need to make C the subject, C को subject बनाने के लिए you just bring it on the other side. It will become C is equals to PR per 4 over CL, and when you take this T to the other side, it will be multiplied there. So PR per 4 into T. That makes it P. What is the unit of P? If you were not able to prove it over here, but forbid, no problem. You just use that unit they have already given to you. You'll just be losing a mark over here then, but you will get the rest of the marks. So pressure SI base units are kg m minus 1, kg m bar minus 1, s bar minus 2. What was R? R was the radius. Radius is length, and that's measured in meters. So you will write meter m power 4, m power 4. And then what is T? T is time. Time is measured in seconds, right? Acha, I've just written here C. The C should not be there. It should be B. Because I've made C the subject, I've just replaced it. What was V? V was the volume. So SI base unit for volume is meter cubed into L. What is L? It's the length. That's also in meters. So simplifying it, m power 3 and m will make it m power 4. And you can just simply cancel this out. M power 4 and this with m power 4 will also be cancelled out. So you will be left with kg m minus 1, and this is s minus 2 here, s minus 2 here, and s here. That makes it s bar minus 1. The final answer is kg m minus 1, s minus 1. That are the base units for C. Got it? Any problem, any confusion?
No.
Okay. Then the next question is from 2006, and this is paper 2, question 1. You have to derive the SI base unit of force, and you just did that. SI base unit for force. Force is basically mass into acceleration. Mass into acceleration. Force is equals to mass is kg, acceleration is meter per second square. So it's kg meter per second square. Now, it says a spherical ball of radius r experiences a resistive force F due to the air as it moves through the air at a speed v. The resistive force F is given by the expression this, where C is the constant. Derive the SI base units of C. So you need to make C the subject once again over here, and you will rewrite it this way. C is equals to F over RV. F over RV. That will make it C is equals to F. You have already derived the unit for force, kgms minus 2. So kg ms minus 2 over r. Radius is in meters, and then v is what? V is the speed. So be careful, everything is given in the question. You just need to look for it. So here you just simplify it. It's m at the top and it's m squared in the numerator. So you will rearrange it. C will be equals to kg m, and then bringing m square up here, it will become m power minus 2. S minus 2 was already there. Bringing s minus 1 up here will make it s only. So just simplifying it, m power minus 2 and m. This will make it just m power minus 1, kg m minus 1, s power minus 2, s bar minus 2 and s will make it what? Just s bar minus 1. So it's kg m minus 1, s minus 1, the SI base units for the constant C. Right? Any problem, any confusion?
No.
So this is another question from 2012, June 2012, paper 2-1. You need to state the SI base units of volume. I guess we did this already. Oh, so this is repeated from the specimen paper. It's the same question given. It's just a repeat, so we'll skip it. Okay, this one. Show the SI base units of energy per unit volume are this. So you need to be very careful while reading the question. It says energy per unit volume. Energy per unit volume. Energy per unit volume. So when I say energy per unit volume, it means energy upon volume. And energy is basically work done. It's simply saying work done per unit volume. Energy is work done, right? Energy is work done. Now, what is work done? Work done is force into distance. What is volume? Volume simply has the unit meter cubed, so you do not need to worry about that. Okay, I'll just keep it V right here. For F, I'll replace it with kg ms minus 2. Force is mass into acceleration. The mass is kg, acceleration is ms minus 2. Force becomes kg ms minus 2. Then d, of course, is in meters. Distance is in meters. So I'll write it meters there. Meter cubed in the bottom, in the numerator. And it will become kg m squared and then m minus 3. This m power 3 will come up and will become m minus 3. Then it will be simplified to s minus 2. So kg m power 2 s m minus 3 s power minus 2. Simplifying it further, this will change into m minus 1. So it's kg m minus 1 s minus 2. Proved once again. This is proved. For a wire extended elastically, the elastic energy per unit volume is given by T is a constant, this is the strain, and E is the Young's modulus. So you have not studied Young's modulus so far, but I'll just tell you the formula for Young modulus. Formula for Young modulus is FL over AE. Force into length over area into extension. You will be studying this in detail in the topic of deformation, but for the case of base units, I'll just tell you the formula straight away so that you can mention the base units. So F is the force, F is the force, L is the length, A is the area, in fact cross-sectional area, and E is the extension. That means unit for E would be what? Just meters. Unit for A would be meter squared. Unit for length would be meters. And unit for force will be kg. So just finding the units of force C. In fact, you have to show that C has no units. So you will make C the subject over here. To make him see the subject, he will come up as x over strain squared into E. And what is strain? Strain is extension over original length, right? Strain is extension over original length, so it has no unit. Strain has no unit, right? Strain has no units. Stress is force over area. This is again we will be studying it in the chapter deformation of solid, right? So you don't have to worry about this. So now, what is X is energy per unit volume, and we have already proved the unit for energy per unit volume. It's kg
m minus 1 s minus 2, and then it's strain squared. So you just ignore this because strain has no units, no? You just ignore that, and then Young's modulus. Young's modulus is FL over TE. So if I just write the formula again, FL over E for Young's modulus, Young's modulus is FL over TE. Are you there with me, Asif? It's force, force
Yes.
is equal to ms minus 2 into length, into length. Length is m over A. A is meter squared into E. E is meters. So this will be simplified to kg m power 2, then m squared and n. It will become m power minus 3, and it will come up there becoming m power minus 3 over here. This is s power minus 3. So just simplifying it, m minus 3 and 2, it will become kg m minus 1 s minus 3. For Hence modulus is kg m minus 1 s minus 2. Simplifying it further, it will become equal to this kg will go with kg, this m minus 1 will go with m minus 1, this s minus 2 will go with s minus 2. So hence, you are left with 1. That means it has no units. When simplifying and finally getting your answer as 1, it means that that particular quantity has no unit. Right? Got it?
Yes. Yes.
Okay. Moving further in summer 13, paper 2, question B1, you need to determine the SI base units of power. SI base units of power. What is power? Power is force upon area. Force upon area. Force is kg ms minus 2, and area is m squared. It will become kg m power minus 2 minus 2. Simplifying it, m power minus 1 and m will become kg m power minus 1 s power minus 2. Kg m minus 1 s power minus 2. Then it says figure 1.1 shows a turbine that is used to generate electrical power for the wind. The power available from the wind is given by P equals CL power rho V Q. So everything is given here. L is the length, rho is the density, V is the experience, C is the constant. You need to show that C has no units. So let's do it. Am I clearly audible there?
Yes.
So we once again make C the subject, and this will become P over L power 2 rho V cubed. So it will become C raised to P. What is P? It's pressure, power, sorry, power. And for power, we just use the units to be kg m power minus 1 s power minus 2. Power is kg m power minus 1 s power minus 2. What is L? L is length. The length is meter squared. Length is meter, and square of meter will make it meter squared. I'll just simply write it down. You don't have to put these brackets there. I'll just make it meter squared. Then what is next? It's rho. What is rho? It's density. Density is kg m power minus 3. kg per meter cube, kg per meter cube. Rho is kg per meter cube. It's density, kg per meter cube. Then the next thing is V. What is V? V is the speed, and speed is meters per second. So it is meters per second per 3. And it will become E is equals to kg, kg, m power minus 1, s power minus 2 over, I think there's something wrong. It's kg, power is kg minus 1 s minus 2. And then what is it? It's meter per second. Speed, right? Density is mass per unit volume, so it's kg per meter cube. How is it possible? You might be ending up with some yourself with density, speed, density, speed. Let's look here again. kgms minus 2. Why bad? What did I do? How can power be force upon area? Power is equals to force into distance upon area. Hmm, this is wrong. Are you there with me, Harsh?
Yes, I was thinking about that. The formula looked wrong.
So, yeah, you just sit down because देखो मैंने बोला ये anyone can be wrong, right? So if you have any sort of doubt, I'll be more than happy if you just you know figure it out. It's force into distance over area, right? That's work done upon time. Upon time. Work done upon time. Force into distance upon time, right? Force is kg ms minus 2. Distance is meters. Time will be in seconds. So just simplifying it, it will be kg empire 2. I'm just get it further. Kg empire 2, and then s minus 2 up there and s1 down there. So it will simplify to s will come up there, s bar minus 1, it will simplify to s minus 3, s bar minus 3. So it is kg empire to s bar minus 3, right? Kg empire to s bar minus 3. Now just correcting this equation, uh, this unit here is kg empire to s bar minus 3. kg empire to s bar minus 3. And then solving,
How's the power minus 3?
come again.
How's it s power minus 3?
Okay. So when you take s up there, it will be s bar minus 1. It will become like this, s bar minus 2 and s bar minus 1,
Oh, okay, okay.
right? So it becomes kg empire to s bar minus 3. Okay. Here we have already done this. For this one, it's kg m2 s minus 3 as it is copied and is length and then squared, so meter squared. Then rho is density, density is mass per unit volume, is kg per meter cube. V is speed, speed is meter per second, and it's cube, so meter per second. Okay, so it will become mv power 2 kg m power minus 3 m power 3 s power minus 3.
right?
Yes.
So just simplifying it now, I have once again written it as 2, it should be s minus 3. We just simplify s minus 3 goes with s minus 3, kg cuts with kg, then here m power 3, there's one more m being left out, it's kg m power minus 3. Why have I written it m minus 1? M power minus 2, fact plus 2. So basically m power plus 2 will cancel with m power 2, and then s power minus 3 will cancel with m power 3. So C is left with no units. You got this?
Should we write 0 or no units?
No, you just write no units. You write C equals to 1, and then that's no units. Right?
Okay.
Okay, here you just have to calculate the speed of the weight. But we are doing SI based units. We call it skip here. Okay, here it's asking us again base units for force. So it is kg ms minus. Okay, two wires each of length L are placed parallel to each other at distance x apart as shown. Each wire carries a current I. The currents give rise to a force F on each wire given by this equation. So this is the equation of the force. Now is constant, you need to determine base units for K. What base units for K? When you're trying to find the base units of K, you make K the subject. So K becomes equal to K is equals to Fx Fx over I squared L. So K becomes equals to what is F? Kg ms r minus 2. What is X? Distance. So Kg ms minus 2 into M. What is I? Current. Current is measured in amperes. So it's amperes squared. What is L? It's meters. K becomes equal to kg m power 2 s power minus 2 over a squared a squared into m. So just simplifying it further, m in the numerator, in the denominator, will when goes up there in the numerator, it will become kg m power minus m power just m. You get m power minus 1 and m power plus 2 makes it m, and then s minus 2 will be there as it is. A power 2 going up there will become a power minus 3. Yes, these are the base units. Any problem, any confusion?
No.
So sketch the variation. Okay. Again, you don't have to do this right now because we're just looking forward. Base units. So show that the SI base units of power are kg m2 s minus 2. Show that the SI base units of power are kg m2 s minus 3. Power is what work done upon time or force into distance, force into distance upon time.
So that will become kg versus kg ms minus 2 into m over s. So simplifying it, it will become kg m squared s minus 2 up there and s in the denominator. S will come up, it will become s bar minus 1. So s bar minus 1, s bar minus 2 makes it s bar minus 3. So there you go, kg m bar 2 s bar minus. Now, here's an interesting question, a little tricky, not that much. It's q upon t. Q upon t is equals to cat upon x. Now, what is Q upon t? It's the rate of thermal energy, rate of thermal energy. Here's an interesting thing. What does rate mean? Rate means upon time. Upon time. The rate of thermal energy means thermal energy upon time. It simply means energy upon time. It simply means work done upon time. Energy upon time, work done upon time. What is it? It's power. Simply Q upon T. Q upon T is what? Power. Q upon T is power. Right. Got it? The Q upon T is power. Okay. I'll simply rewrite this equation. Are you there with me, Master?
Yes.
So power is equal to cat upon x. Done this. Now what we have to do? We have to find the base unit system, right? What is x? Thickness. What is T? It's temperature. What is A? It's area, right? And what is power? It's just proof this. Okay? So we'll just simply write it down. It makes C the subject first. So C will become Tx. C will become Tx upon Tx upon Ag. Is what? Tx upon Ag. So what is P? It's Kg m bar to s bar minus 2. What is x? It's thickness, meters. What is area? It's area, so meters squared. What is T? It's temperature, so Kelvin. Now simplifying it, it becomes kg m bar 2. In fact, I'll just make it more simple. M bar 2 gets cancelled with m bar 2. It will become kg m s minus 3 k power minus 1. These are the SI base unit kg ms minus 3 k power minus 1. Getting the point?
Yes.
Now it says underline all the base quantities in the following list. Base quantities. Base quantities. Quantities, not units. Disclaimer, not units. Most of the people begin to highlight units and vice versa. So base quantity is current. Base quantity is mass. Second is a unit of base quantity, but not base quantity. Temperature, temperature is a base quantity. Temperature is a base quantity. Weight, no, not a base quantity. Charge, no, not a base quantity. Ampere, it's a unit of base quantity. It's a unit of current, but not a base. Here you have to define base quantities. Right now, the potential energy stored in a stretched wire is given like this. EP is equal to half T sigma squared V. So this is the strain, the constant, this is the volume. Strain, I just told you, it has no unit. Strain has no unit because strain is extension over length. Extension is in meters, length is in meters, so they just you need to determine the SI base unit of speed. So we make C the subject, T will become T equals to, remember you have to ignore the constants while doing the unit conversion thing. So it's EP, elastic potential energy or just potential energy, equals upon strain. मैं strain को भी वैसे लिख रहा हूँ लेकिन I'll just ignore it into V because strain has no unit, right? So elastic potential energy is basically work. Any energy stored, any energy converted is work, right? And what is work done? Work done is force into distance, right? Force into distance. And what is V? V is the volume. Well, just ignore this because this is a constant. Force is kg ms minus distance is in meters and volume is in meters cubed. So it will become kg m power 2 s power minus 3 over m. I'll just bring m up there. I'll just bring m up. So when I bring m up here, it will become m power. So m power 2 and m power minus 3, it will become kg m power minus 1 s power minus 3. So kg m power minus 1 s power minus 3. Are you getting the point? Yes or no? Ashir, are you there with me?
Uh, oh, can you repeat this because where did the half go?
Where did the half go? That's what you said?
Yes.
Right. So half is a constant, right? And while we're finding SI base units, we just ignore the constants because constants have no units, right?
Okay.
Okay. So I hope you're doing the working along. Yes or no?
Yes.
Sure. So let's do one more question. Use the definition of power to show that the SI base units of power are this. So then it's so many times. Power is work done upon time or energy converted. Now it's saying definition of power. Power can have many formulas, but the defining formula for power is what? Work done upon time. Work done is force into distance upon time. Force is kg ms minus into distances in meters over time seconds. So it will become kg m power 2 s power minus 2 and s in the denominator will become s power minus 1 up. So it becomes kg m power 2 s power minus 3. Proved. Use an expression for electrical power to determine the SI base unit potential difference. Potential difference, PD or voltage, what? Work done upon charge. What's work done? It's force into distance. So what is charge? Charge is current into time. Current into time. What's work done? It's kg ms minus 2 into m. So it will become m power 2. Hmm? Force is kg ms minus 2 into m. It will become kg m power 2 s power minus 2 over current is in amperes, time is in seconds, ampere seconds.
Simplifying it, it will become kg m power 2 s power minus 2 and s in the denominator will become s power minus 1 up here. Ampere will come up and become ampere minus 1. It is kg m power 2 and this will simplify to s power minus 3 kg m power 2 s power minus 3 a power minus 3. Right? Any problem, any confusion? Got it? Yes or no? Ashir, are you there? Hello? Ashir, can you hear me?
Yes. I got disconnected.
Oh, okay. To use the definition of work done to show the SI based units of energy on this. Definition of work done. What is the definition of work done? Work done is equal to force into force into distance moved in the direction of force. So it will be force is kg ms minus 2 and distance is in meters. So it becomes kg m power 2 to s power minus 2 coulomb. Right? Determine the SI base units of resistance. What is resistance? Voltage over current, isn't it? And what is voltage? Work done per unit charge, isn't it? And what is work done? Work done is force into distance divided by the charge over current. So what is force? Force is kg ms minus 2. Kg ms minus 2. What is distance? Distance is in meters. What is charge? Charge is current into time, so it becomes ampere second. And what is current? Current is simply in amperes. So just simplifying this side will become kg m power 2 s power minus 2 over ampere second over amperes. This will become kg m power 2 s power minus 2 over ampere squared into seconds. And this will become kg m power 2 s power minus 2 and s power minus 1 and a power minus 2. This s will go up, become s power minus 1. This a square will go up and become a power minus 2. So simplifying this, we get kg m power 2 s power minus 3 a power minus 2. You could have done it in one step up there, but it's just simplifying in order that you get to know everything in this. We could have simplified it over here as well. This expression, we could have just made it force into distance divided by current into time, or simply I'm using this force into distance, charge is current into time, so it's current squared into time, right? And this will become work done is what? Work done हमने यहाँ prove कर लिया था ना already. So it is kg ms minus 2 kg into s power minus 2 over ampere squared and s. So it simplifies again to kg m power 2 s power minus 3 and a power minus. It's the same thing in one line here now. Okay.
Yes.
So any problem, any confusion?
All clear.
Okay. I would want you to complete the rest of the questions. We have done a good number of questions from 2006 till 2016. Okay. See you then in the next class. Until then, Allah Hafiz.
Allah Hafiz.